What if you could risk a small amount of money and control a much larger outcome? What if you could win big when you're right, but strictly limit your losses if you're wrong? This is the core idea behind options, one of the most powerful instruments in finance. At the most basic level, an option is a deal about a future price. You're not buying the asset itself, you're buying a right. A call option gives you the right to buy something later at a fixed price, a put option gives you the right to sell it. You pay money upfront for that right. That upfront payment is the price of the option. Options are part of a much broader family of financial instruments, which are called derivatives. A derivative may be simply thought as a contract between a buyer and a seller. It can take various forms, but in all these forms it has to satisfy four main very important conditions. There is an item called the underlier which can or must be sold or bought. There is the premise of a future act which must occur, such as a sale or purchase of the underlier. There is a price at which the future act must take place, and there is a future date by which this future act must take place. Contracts very similar to options have been used since ancient times. It's said to be that the first option buyer in history was the ancient Greek mathematician and philosopher Thales of Miletus, considered one of the seven sages of ancient Greece. Thales predicted that at a certain time, the season's olive harvest would be larger than usual, and so during the off season, he paid a small amount of money to reserve the right to use several olive presses the following spring. And when spring came, the harvest turned out to be actually very large, and so he was able to rent the presses at a much higher price than what he originally paid. This is the first time history has ever registered a financial action so close to an option contract such as this, but quite some time is going to pass until this type of contracts will actually be regulated. During the 1960s, the grain futures market had stalled, prompting the 120-year-old Chicago Board of Trade to search for a new business opportunity. By 1969, the CBOT had declared to establish a new formal marketplace, which would come to be known as exchange traded options. The US Security and Exchange Commission approved the initiative as a pilot program in 1971, and 2 years later it officially registered as the Chicago Board Option Exchange as a national security exchange. So in 1973, the Chicago Board Option Exchange was established. After that, options started being traded with standard contracts, regulated exchanges, and a clearinghouse, which stands in the middle and helps guarantee that both sides respect the contract. Today, there are two main ways options are traded. There are the exchange traded options, which are standardized options traded on official exchanges, and there are the over the counter options, which are private agreements and they are customized and their terms can be arranged to the need of the two parties. An option contract has certain characteristics. It takes the name of a call option if the holder has the right to buy, or we call it a put option if the holder has the right to sell. The option premium is the price paid by the buyer to acquire the option. It is the cost of the contract. The strike price is the predetermined price at which the underlier may be bought or sold if the option is exercised. The maturity is the expiration date T. The quantity of the underlier covered by one option contract, for example, one equity option often represents 100 shares, the rights and obligation of the option. For example, the buyer has a right but not an obligation to exercise, while the seller or writer has the obligation to fulfill the contract if the buyer exercises. In the end, there is the payoff age, which is the amount of money an option contract is worth at expiration. The payoff is a rather intuitive but deep concept. I'm going to give a rigorous definition first, then I'm going to carefully explain it. A payoff age is a random variable expressed as a function of the terminal price, which is the price at maturity, or the entire path of the underlier. The price of the option contract is then a result of the current valuation of that payoff. A random variable is a function defined on all the possible outcomes of the world, so its value depends on how uncertainty is realized. Think about an empty box. You and your friends can put inside it whatever you want, plenty of things. Its weight depends on the things you and your friends put there, so the weight of the box is uncertain until the content is realized. So an option is a derivative contract whose payoff age is a measurable function of the future state or path of an underlying asset. But what's so special about options? Most ordinary instruments give you a roughly linear exposure. If the asset goes up by X, you gain roughly X. If it goes down by Y, you lose roughly Y. An option does not behave like that. Its payoff is asymmetric and state dependent. It reacts differently depending on where the underlying ends up, how volatile it is, and how much time is left. A stock is mainly a bet on direction. An option is not only a bet on direction, it is also a bet on volatility, time decay, skew, tail risk, and path effects. Convexity is one of the deepest reasons options are so special. Convexity means that the payoff responds to changes in the underlying in an accelerating way, not a constant one. If a payoff is linear, every extra unit of move gives you the same extra gain or loss. If a payoff is convex, the effect of an extra unit of move becomes larger and larger as you move farther in one direction. If we take a straight line, a move from x equals 1 to x equals 2 has the same marginal effect as a move from x equals 11 to x equals 12. If we take a convex curve like a parabolic curve, a move from x equals 1 to x equals 2 changes the payoff by 3. But a move from 10 to 11 changes it by 21. The same 1 unit move matters more when you're farther out. This is convexity. So when we say an option is convex, we mean that as the underlying moves in the favorable direction, the sensitivity of the option increases. Another very crucial thing about options is that they make time a priced object. In options, time is not just the duration we wait before learning the outcome. Time itself is one of the determinants of value. Consider two otherwise identical call options. Same stock, same strike price. One expires in 1 week and one expires in 6 months. The 6 month option is usually worth more because it contains everything the 1 week option has, plus more chances for favorable moment. There is more time for the underlying to cross the strike, volatility to create favorable states, news to arrive, and market conditions to change. So extra time expands the set of possible future paths under which the option pays off. That extra of possibilities has value. So remaining maturity is not just merely a date label, it controls the space of future states that can still rescue or enrich the option. At every instant, there is less time left for favorable events to occur. If nothing else changes, an option is gradually losing one of its most valuable ingredients, which is remaining possibility. That loss is called theta decay. Theta is the sensitivity of an option value to time passage. This loss is not uniform. A day lost when there are 300 days remaining is not the same as a day lost when there are 2 days remaining. So near expiry, time often becomes much more dense economically. Because close to expiration, the difference between there is still a chance and there is almost no chance changes very rapidly. So the options time sensitivity is often strongest near expiry, especially around the strike. So we talked about theta and the fact that it represents time decay in an option. In option pricing theory, the Greeks are partial derivatives of the option price with respect to the underlying parameters. Formally, each Greek is a sensitivity. So there is theta, which measures sensitivity to time, and it's typically negative for long options because of time decay. Then there is delta, which measures sensitivity to the underlying price. There is vega, which measures sensitivity to volatility, and there is rho, which measures sensitivity to interest rates. Then there are second-order Greeks, and then there are higher-order Greeks, which are based on first-order Greeks, and so on and so forth. But there are a lot of these, but the main ones are these ones, so delta, vega, theta, and rho. What I like most about options, and the reason I find them truly useful, is that they reveal the market's distributional beliefs. An option chain is not just a price list. It contains information about how the market is pricing future states of the world. I'm going to say it again. It contains information about how the market is pricing future states of the world. So options are not merely tradable contracts. They are also a lens into the market's risk-neutral distribution. This is mathematically profound to me. From option prices, one can infer information about the entire distribution of future outcomes, not just an expected value.